Hello there and welcome to our third lecture video. This is all about functional groups and nomenclature of organic compounds. At the end of this lecture video, you should be able to first describe and differentiate functional groups and classes of organic compounds, and second is to give an appropriate and acceptable name to each class of organic compounds. So to start our discussion, I am showing here the periodic table but with the highlighted elements. So why are these elements highlighted? Remember in our second lecture video, these elements, aside from carbon, you have nitrogen, hydrogen, oxygen, fluorine, chlorine, bromine, iodine, phosphorus, and sulfur. These are your elements that bond with your carbon that makes it organic. Okay, so please remember that. Now, I want to introduce to you a term which we call your heteroatom. Here's the Greek derivation for that term, but let's focus more on the definition. So, by definition, it is any atom that is not carbon or hydrogen. So, I've shown you a while ago the periodic table. Then that means certain elements will qualify as the heteroatom. And these are your nitrogen, oxygen, phosphorus, sulfur, and your halogens, fluorine, chlorine, bromine, and iodine. Okay? Now, let's recall how elements bond together. So I am showing here a diagram on how your carbon-hydrogen bonds are formed. So we have a carbon-hydrogen single bond. For oxygen to bond with your carbon, you can form two bonds. You have your carbon-oxygen single bond or you have your carbon-oxygen double bond. Okay? Now for nitrogen, we have three. So you can either form a carbon-nitrogen single bond, a carbon-nitrogen double bond, and we also have a carbon-nitrogen triple bond. But let's go back dun sa ating carbon-carbon. So for carbon, you have here the formation of either the single bond, carbon-carbon single bond, a carbon-carbon double bond, or a carbon-carbon triple bond. So why am I showing this? Because some of our functional groups later on will feature some of this yung gantong bonding. So you will see later on what will be the name of the functional group pairing this carbon-carbon double bond. How about a carbon-carbon triple bond? So there will be a name. So sa mga functional groups natin, you will see this types of bond. Okay? Yan. So now let's define functional groups. So functional group is an atom or group of atoms within a molecule that shows a characteristic set of predictable physical and chemical properties. And this is by Bettelheim 2013. So earlier, ang pinakita ko sa inyo is just a pair. So you have your carbon to a certain element. But we can also team up your atoms. Like for example, carbon and you have your oxygen. And then what if we add another hydrogen? So that will form a definitely it will form a group of atoms. So that group of atom is what we call your functional groups. Okay? So I will be showing you several slides containing your functional groups, and these are many functional groups. So please bear with me. So let's start with this simplest. So what my strategy is, I will be showing you the functional groups by uh, kung anong klaseng element yung nakabond with your carbon. And let's start with your hydrogen-containing functional groups. So the very first class or family is what we call your alkane. So in the structure is just a carbon-carbon single bond. And you have your structure, di ba? Dapat supposedly may element na nakabond dyan. But let's imagine that you are going to put here hydrogens. So if that is the structure, then that is an alkane. According to some books, they will not consider alkane as a functional group. So none. The functional group is none. So why? Because In fact, in organic chemistry, alkanes are the very simplest organic compound. It's just made up of carbon-carbon single bonds, and then you just supply the rest with hydrogens. Now, I want to introduce to you a term which which serves as an umbrella. Kumbaga, this is a family, and then you have a bigger family, you call that your hydrocarbons. So what are hydrocarbons? So based on the name, it's a compound that are made up of carbon and hydrogens. So it's just carbon and hydrogens only. So um, we have other members of the hydrocarbons. So ibig sabihin nito, basta it's made of carbon and hydrogen, then that is under hydrocarbons. Later on kasi makikita nyo na also yung multiple bonds natin, yung double and triple bonds, will also belong to hydrocarbons. It may be aliphatic or aromatic. So when you say aliphatic, it's straight. So think of a straight chain of 10 carbons, and in between each carbon you have a single bond. So that is an alkane. So that is straight. Or it could also be aromatic. So when say aromatic, it forms a ring. So, but heads up, it doesn't mean that yung structure nyo ay naka-ring o nakabilog siya makes it automatically aromatic. So there are certain conditions that will make a structure or an organic compound aromatic. So if this is the first time that you heard this, you can think of Li in the aliphatic as line. So that is a straight. And then for aromatic, just remember letter R, then that is for the ring. Okay? So that is the first family that belongs to the hydrocarbons. And sabi ko nga earlier, there is no functional groups because of its very simple structure. It's just made up of carbon-carbon single bond, and you just supply the rest of the structure with your hydrogens. Now, I want to direct your attention to these shapes. So in our geometry or mathematics class, we call this your polygons. But these are also representations of your organic compounds. In fact, we call them your cycloalkanes. These are alkanes because these are made up of single bonds, and it's cyclo because as you can see, it's in a ring. It forms a ring, di ba? So the very simplest polygon natin in mathematics is made up of three. So triangle, you have your square, your pentagon, your hexagon, your heptagon, and your octagon, and so on. But let's imagine that in each corner, you have a carbon. So for example, this triangle, it is composed of three carbons in a ring. This square is made up of four, and so on. So these are cyclic. So these are cyclic structures. Okay? So we will call this your cycloalkanes. Now, let's go on and include the other members of the hydrocarbons. So, alkenes, the functional group now here is your carbon-carbon double bond. Okay? So, and also your alkynes, these are your carbon-carbon triple bond. So, in comparison do sa ating alkanes, walang functional group doon kasi it's just a carbon-carbon single bond. But itong kakaiba dun sa alkene and alkyne, kinonsider sila as functional group because of the difference in the number of bonds between your carbons. Yun nga, alkanes natin, you have a double bond, and your alkynes, you have a triple bond. So let's try to pronounce your first three functional groups. It's alkane, alkene, and alkyne. So it's alkane, alkene, and alkyne. So these are your members of your hydrocarbons. We also have another member, which is what you call your aromatics or arenes. And the functional group, the functional group looks like this. So you have here a 6 carbon in a ring. So nakabilog siya. But what's peculiar or kakaiba sa kanya is you have this alternating single double single double single double bonds. So we call this your conjugated we call this your conjugated double bonds. Conjugated double bonds. Okay? So please bear also the shape. It's hexagonal siya. And we can also show the structure this way. So this structure, the second structure I'm showing here is just same with this one. Okay? So these are just the same. The the difference is just the double bond. For example, this one. There's a double bond between the two carbons, but in this same side of that structure, you have now a carbon-carbon single bond. Okay? So we can also simplify the structure, the first structure like this. You draw a hexagon and then you draw the double bonds, indicating the position of the double bonds. So we have three double bonds that are separated by a single bond. So this is what I meant. You have a double bond, a single, double, single, double, single. So these are conjugated. So have your alternating. So if you're not used to the term conjugated, you also use the term alternating. So you have an alternating double bonds. And since this is the structure, this is the simplified structure of the first one, you can also draw the simplified structure of this second by rotating. So instead of, let's draw na lang. So if this is your hexagon, you have your double bond here, double bond, and double bond. So as you can see, in the first structure natin, this is simplified, kung nandito yung double bond kanina, nandito na siya sa kabila. Lumipat siya, and then umiikot kasi yan. So that's why scientists, organic chemists, will also use this structure. You have here a hexagon with the circle inside, meaning the electrons, di ba? In our bonds kasi, yung mga bonds natin yan ay created by your electrons. So these electrons are transferring. So it transfers here. Hindi pwede magkatabi ang double bond, so this one will also transfer here. And since, again, may formation ulit ang double bond na magkatabi, adjacent, this double bond here will transfer here. So as you can see, the electrons are moving and moving in the structure. So that's why the accepted structure is a circle inside a hexagon. So these are all accepted structures. So this is called your aromatics or your arenes. Now, let's jump to another functional groups. This time, these are halogen-containing. So when say halogen, these halogens, these are your fluorine, your chlorine, your bromine, and your iodine. So we have here alkyl halides, or we also call them your organohalides. And the functional group is like this. You have a certain element, we represent it with X. It is bonded to carbon. What is this X? This X is your fluorine. It could either be your fluorine, your chlorine, your bromine, or your iodine. So as you can see, it only forms a single bond. Diba? Remember, in our Lewis structure drawing, you have 7 valence electrons for your halogens, but only one electron will be used for the bonding. That's why we have a single bond between your carbon and your halogen. So this is your alkyl halide. Sir, is it possible that you have, after the carbon, you can form a double bond? Yes. Can you form also a triple bond? Yes. So these are all under your alkyl halides. Now, what is this aryl halide shown here? In aryl halide, you have here the arenes or the ring. By the way, we can call this ring, yung sa ating previous slide, benzene. So we will call this your benzene ring pala. This is your benzene ring with the formula of C6H6. The chemical formula is C6H6. So if you if you saw a structure of an organic compound with this benzene ring with a halogen attached to it, so we will call that your aryl halide or aryl halide. So these are your halogen-containing functional groups. Okay? So the idea here is you have a halogen. It could either be fluorine, chlorine, bromine, or iodine, and it is bonded to carbon. Single bond only. So, yon. Okay? So, we have now alkane, alkene, alkynes, cycloalkanes. We can also form pala cycloalkenes and cycloalkynes. So, that's an additional. And then we have your arenes or aromatics. And this time we have your alkyl halides and your aryl halides. Now let's go to oxygen containing. So for oxygen containing, remember we can form a carbon oxygen single bond or a carbon carbon double bond. Let's start first with your carbon oxygen single bond. So we have here a class and family of alcohols and phenols. So what will be the difference? For alcohols, you have a carbon bonded to oxygen and the oxygen is also bonded to hydrogen. Remember, if you have a carbon-oxygen single bond, then that means on the other side, meron ka pang free electron for bonding with another element and this time we will bond it with your H. So we will call this your hydroxyl group. Hydroxyl. So if your structure contains OH, you call that your hydroxyl group. So the OH group, o yan, pwedeng OH group or hydroxyl group, so those are acceptable terms. Your hydroxyl group is bonded to your carbon. So if that's the structure, this is your functional group, your COH, then that is an alcohol. That's why we have your isopropyl alcohol, ethyl alcohol, methanol. So something ending with all, that is an alcohol. Now, for phenol, what's the difference? So, if you remember, sa ating halides kanina, meron tayo nung halogen bonded to either the just alkane or alkyne. Tapos, meron tayong isa nung naka-bond yung halogen sa benzene ring. So, in phenol, medyo ganun din, similar din siya. You have the benzene ring here, and then you have an OH group attached to it. So we will call that your phenol. Okay? So that is the structure, the difference between your alcohols and phenols. So your alcohol, that is just you have either an alkane, then you have an OH group attached to it. So, kumbaga kung sa alkane ito, 'di ba? Ang alkanes natin, you have your carbon and you just surround it with H. Imagine you have yung isang H na yon, yung isang H doon, paltan mo siya ng OH, that becomes an alcohol. Sa benzene ring, ganun din. Di ba? Yung ating C6H6, so you have 6 carbons and then you have 1, 2, 3, 4, 5, 6. Supposedly, this is the 6 hydrogen. So the 6 hydrogen there, you remove that and then you replace that with OH group, then that makes, that creates a phenol. Okay? So, that is your oxygen. These are just the start of your oxygen-containing functional groups. So, ang gawin natin ngayon, tuloy natin, ano po yung mga functional groups under oxygen-containing? So, we have your ether and your epoxide or epoxide. So, the functional group for ether looks like this. So, you have an oxygen in between two carbons. So, that is the appearance of an ether. So, oxygen, para siya yung nasa gitna ng dalawa nating carbons. And for epoxide naman, imagine that these carbons, you have your oxygen in between the two carbons. The two carbons will bond with each other. So, we will form a shape, and that is a triangle. So, if your structure, your organic compound, structure contains this arrangement of your atoms, you have your partial triangle with the oxygen in one vertex, then that is an epoxide. So that is the appearance of your epoxide. Okay? So we're now done with the four functional groups ng oxygen containing carbon-oxygen single bond. But now let's proceed with the other one kasi ito yung may carbon-oxygen double bond. So this is your carbon-oxygen double bond, di ba? In our drawing of our Lewis structure earlier in this lecture video. So this is the appearance. So you have your C double bond O. We will call this your carbonyl group. So this carbonyl group, if we will attach elements here on either side, we will form different functional groups. So from carbonyl groups, we will give rise to different functional groups. Okay? So let's start now with these two terms. You have your aldehydes and your ketones. So for aldehyde, it looks like this. Of course, you have here the carbonyl group, and to the one side natin, sa isang side natin, this is bonded to hydrogen. And then the other side, your carbon in the carbonyl group, please take note how I pronounce it or how I describe it. The carbon in the carbonyl group is bonded to another carbon. So this is, diba, this is your carbonyl group. This is your carbonyl group. This is the carbon of that carbonyl group. And this is bonded to your another carbon. And this is what you call your aldehyde. So, yung aldehyde kasi, usually nakikita yan sa dulo ng structure. So as you can see, hydrogen is the last element bonded. And di ba hydrogen is just forming a single bond with, it forms a single bond with carbon. So if this is bonded here, ito na yung dulo ng structure. Nasa dulo na siya. Kasi, di ba hydrogen cannot form multiple bonds pa. It can only form a single bond. So, if this is a structure, you have a carbonyl group and then you have the H, then we call that your aldehyde. Now, how about your ketone? So, imagine that this hydrogen, ito, instead of hydrogen here, you have another carbon. So, the structure will look like this. So it looks like you have a carbonyl group in between carbons. So this is what you call your ketone. So I don't know if you're familiar with that substance, but you're actually using a very well-known ketone in your house, and that is your acetone. So acetone is one of the members of your ketone family. Okay? Actually, this is the structure. If we will supply hydrogens here, then this is the structure of your acetone. The acetone is the simplest. Acetone is the simplest ketone in the group or in the family. Okay? So, yon, aldehydes and ketones. So, the if yung aldehyde natin can be found in the end or the in the usually kasi nasa ending yung aldehyde group. It's in the end of the structure. Yung ating ketone is somewhere in between. So this carbon, you can put another carbon, and so on. It depends on the structure. So you will always see your ketone in between the structure. This is usually in between. Your aldehydes, these are formed or can be found at the end of your structure. Now, please take note of this structure of your aldehyde. You have your C double bond OH. And we will be using this to give rise to other functional groups. So this is your aldehyde. You have their C double bond OH. Now what if this H, we will remove that and we will replace this with other elements or other groups or pairs of elements. For example, this H in the aldehyde we will replace this with OH. So it's like you're adding a hydroxyl group. So it will look like this. You have your C double bond O, OH, and we will call this now your carboxylic acid. Okay? So this is carboxylic acid. So why is it called carboxyl? So yung carboxyl kasi, it comes from the term carbonyl and then hydroxyl. So this is your carbonyl group, 'di ba? Remember the C double bond O, that is your carbonyl, and the OH here is your hydroxyl. So if we will combine the two terms, that will become carboxyl. So that is the feature of a carboxylic acid. Now, if we will replace your H here in the aldehyde with an X, meaning these are your halogens, then it will look like this. You have your C double bond OX, and we will call this your acid halides. Okay? Okay. So, the point of this slide is if we will replace a particular part of the functional group, for example, the existing one is your aldehyde. So we replace the H with OH, or we replace it with your halogens, then it will give rise to another functional groups. Okay? Now this time, let's use the structure of your carboxylic acid. So take note, it's C double bond O OH, and we will replace certain parts of this structure. So you have here, this one is your carboxylic acid. Ayan. So take note of the structure. It's C double bond O OH. So I'm just showing here the exact appearance of the OH. So, di ba ang ating OH kasi ang O lagi siyang naka-bend. So it looks like bent. Yan. So now, you have here a hydrogen. So this hydrogen, we can also replace that with another group of atoms. So for example, this one, your carboxylic acid, we replace that or we connect that with another compound with a C double bond O. Essentially kasi yung mangyari dito, you have two carboxylic acid. Imagine, you have two carboxylic acids that will react with each other. So, what will be the structure? So, ganito yung magiging itsura niya. This is the carboxylic acid. Ito. Yan. This is the first one. And then, di ba, if you have the same compound reacting with itself, yung, di ba, ang ating carboxylic acid, meron siya ng C double bond O. So, the C double bond O will attach to the oxygen. So, the structure will look like C double bond O, O, C double bond O, and then you have another part of the molecule or the compound. So, we will call this your acid anhydride. So, ang idea dito is you have the acid anhydrides, it contains two carbonyl groups. Ito, yan. So, you have two carbonyl groups, and then the carbons of the two carbonyl groups are connected by an oxygen. So, C double bond O, O, C double bond O. So, that is called your acid anhydride. Now, if this hydrogen is replaced with carbon, so let's say you will add carbon here na, so it will look like this. So, you have your C double bond O, O, C, then this is what you call your esters. Okay? So, take note of the difference between acid anhydride and esters. So, yung ating H, pinaltan siya ng carbon, but you have either you will connect the carbon with, yan, ito, carbon in something to eh. Pero yung anhydride kasi natin, carbon-oxygen double bond yung i-connect sa kanya, dito sa oxygen. So, that is the difference between the two. Okay? Now, for the last natin, balikan natin si aldehyde. So, this is your aldehyde. Yung aldehyde natin, yung sa H din, ay palta natin siya ng N o we connect it with a nitrogen and it will look like this. So you have your C double bond O N, and if this is the structure, ito yung appearance or arrangement ng ating atoms. This functional group, the C double bond O N, is what we call your amide. Okay? That is what you call your amide. Going back dun sa ating basic structure kanina ng alkenes and alkynes, but this time, i-ano muna natin, assume natin you have your alkane. So, yung alkane natin, di ba, ito ay C. You surround it with H. Imagine you have H here, supposedly. Then, ganito. So, this is the structure. You have carbon and you surround it with hydrogens. Imagine that you will replace one H, yung isang H natin dito, you replace this with N. So, it will look like this. So, remember N, nitrogen can form 3 bonds. So, that's why we have 1, 2, 3. But your carbon will always form 4 bonds. 1, 2, 3, 4. So, this arrangement natin na carbon-nitrogen single bond, this is also a functional group. So, what is the name of the functional group for this one? So, we will call this your amine. So, the amines contain your C nitrogen single bond. And this could also be, pwede pa natin siyang i-specify. We have here, yan, ito. The nitrogen is bonded to R. So, itong R na to is the rest of the molecule. So, if nakakita kayo ng symbol dyan na R, it means it's the rest of the molecules. You can add here a carbon and you just add another carbon. So, hindi natin malalaman kung meron ba siyang naka-attach pang carbon. So, we just represent it as R. So, yan. So, di ba ang nitrogen natin can form 3 bonds? So, we can add here 1 carbon. Etong natira dito ay mga hydrogens. We can add 2 carbons. So, meaning may isa pa dito. And then, we can also bond your nitrogen to 3 carbons. So, if that is the case, we will call this your primary. Primary meaning you have nitrogen bonded to 1 carbon. Secondary amine means you have 2. The nitrogen is bonded to 2 carbons. And then, you have a tertiary amine when you have a nitrogen bonded to 3 carbons. It is surrounded by 3 carbons. So that's why it's called a tertiary amine. Okay? Now, meron pa tayong isang functional group na meron ding nitrogen, but this time you have the carbon-nitrogen triple bond. And we will call this your nitrile. So the functional group is nitrile. So if your structure contains a triple bond between your carbon and nitrogen, then that is what we call your nitrile group. Okay? So now let's go to sulfur-containing. Bakit napasama ang sulfur dito? So sulfur-containing compounds kasi ay napakahalaga din in organic compounds. So bakit natin siya pinag-uusapan? Kasi alam natin that your oxygen, di ba? Oxygen, it has 6 valence electrons. And isang kapamilya ni oxygen si sulfur. So sulfur also has this Lewis structure. So out of the 6, you have only 2. You have only 2 valence electrons available for bonding. So paano nagkakaroon ng sulfur-containing functional groups? So let's say you have an alcohol, 'di ba? An alcohol, you have a hydroxyl group bonded to carbon. Now imagine your oxygen here is replaced with sulfur, then we will call it another functional group. So this time we will call it your thiol. So let's say itong carbon na to, let's represent it as R. So if the functional group is RSH, we will call that your thiol. Okay? So essentially, yung mga inaral natin kanina ng mga oxygen-containing functional groups na yung carbon-oxygen na single bond, papalitan natin siya ng sulfur. So for example, yung ester natin, yung yung ating, this should be ether. This one is ether pala. Sorry. So ether natin, the ether natin is the COC. Then let's replace the oxygen with sulfur. It will become like this. So you have your sulfur in between two carbons, and we will call that your sulfide. Okay? So it's a sulfide. Sulfide yung functional group niya. Now, if we have two thiols reacting with each other, so imagine you have in your organic compound, you can find there two thiol groups. These thiol groups can react with each other. So essentially, ang mangyayari kasi dyan, the hydrogens will be removed, and then your sulfur, di ba, mayroon pa siya magiging isa dyan. Isa pa, tag-isa sila. So the valence electrons of your sulfurs upon removal of your H, yan, alisin yung H, yung mga valence electrons nila, tag-isa, can be shared amongst themselves, and they will form this new bond. So this one is your sulfur-sulfur bond. We will call this your disulfide. So bakit siya di? Kasi dalawa. Sulfide meaning S. So you have the presence of two sulfurs bonded together in the structure, and we will call that your disulfide functional group. Okay? So yan. So yan ang ating mga functional groups. These are just some of the functional groups. Madami pa talaga, but in the context of our subject for this semester, we will focus mainly on this functional groups. Okay? So I have here a challenge. So we can identify. Can we identify the functional groups present in this structure? So isa-isahin natin yung mga functional groups present in this structure. So I will start with this one. So itong mga nakikita nating hexagon with the double bonds alternating, we call this your arids. So we have three of it. So ito at ito. Okay? So ano pa ba? We can, pwede natin siyang, simulan natin ng isa-isa. This part, you have a nitrogen. And imagine, di ba, this is a carbon, this is another carbon. So, in effect, ito ay magiging amine. So, itong part na yan. But since itong nitrogen na to is bonded to a carbonyl, so itong buong ito, yan, we will call this now your amide. Kasi it's CO double bond N, that is an amide. Okay? This part, it contains your benzene ring, your arine, with your fluorine. So ito, pwede natin siyang tawagin na aryl halide. So aryl halide siya kasi mayroong fluorine na naka-attach dun sa benzene ring. This part of the structure, meron kayo nakikitang may mga double bonds. So the double bonds here, these are your alkenes kasi may double bond. This part, you have nitrogen. Nitrogen connected to carbon, another carbon, and another carbon. This is also another amine. Specifically, it's a tertiary. So, siya parang number 3, and then you have the degree sign. It means tertiary. Okay? So, it's a tertiary amine because it's connected to 3 carbons. So, as we go along, ayan, may OH tayo, another OH. So, these are your alcohols. Okay? Dahil may OH, may hydroxyl group attached to it. And then, for the last part, eto na. Ito, OH din yan. Pero kasi ito ay bonded with the C double bond O. So this is your carboxylic acid. Okay? So ilan ang ating na-identify? We have arenes 1, amines 2, amide pangatlo, alkenes pang-apat, aryl halide pang-5, you have your alcohol 6, and then carboxylic acid 7. So in this structure, I know you're familiar with this one, your atorvastatin, we have 7 functional groups present in the structure. Okay? So you also try to pause this lecture video and then identify naman the functional groups present in your melatonin. So this is your melatonin compound. Okay? So um, try to decipher or identify the functional groups present in the structure. So we almost enumerated all of the functional groups, but the question still remains, why functional groups are important? So we have here 4 reasons. So first reason is this one. They undergo the same types of chemical reactions no matter in what organic molecule they are found. So bakit ganyan? Sabi, if you have a functional group present and you saw it in another compound with that same functional group, yung kanilang properties ay magkakapareho. 'Di ba? Kung babalikan natin yung definition ng functional group, sabi doon ay these are groups of atom within the molecule that shows a characteristic set of predictable physical and chemical properties. Kaya natin kaya natin na kaya natin ginupo-grupo yung organic compounds kasi napakadami nila. Hindi natin sila maaaral ng isa-isa. So, maganda kung meron sila ng family that they belong. Yung family na yun, as a family, meron silang properties o meron silang characteristics na nagde-define sa kanila. So, yun yung idea ng ating reason number 1. Na kapag nakita natin yung functional group na yun na present into two similar compounds natin, then magkakaroon sila ng similar na they have the similar properties. This time, ang property nila is yung reaction. So, let's show it. So, for example, this one, this is your ethylene. So, ethylene is the two carbons natin na may double bond. So, ethylene. So, there's a double bond represented by the red. Yan, yung red. Now, if this ethylene undergoes reaction, we call this your bromination. Yan. We call this your bromination. The bromination reaction is the addition of bromines. So, what will happen here is, yung ating double bond ay sisirain muna. It will be broken first, then you will attach the bromines. So, as you can see, nasira, naging from carbon-carbon double bond, it became carbon-carbon single bond here. And then, yung nasirang bond na yun will be used for the creation of the carbon-bromine bond. So, the bromines are added here. So, di ba supposedly kasi yung carbon ay, kung ito ay hindi siya alkene, dapat meron siyang tatlong nakakabit sa kanya yung carbon. Or apat talaga. Yung pang-apat kasi is the carbon-carbon. So, ang nangyari is nagkaroon tayo ng creation ng carbon-bromine bond. So, ang point lang dito is if you have another compound, let's say you have your mentene. So, si mentene, meron din siya nung double bond. So, there's a double bond in the structure, di ba? Napaka complicated na nung structure ng mentene, but the point there is mentene and ethylene, they both contain your carbon-carbon double bond. So, if this double bond ng mentene will undergo also bromination, the addition of bromines, magkakaroon siya nung same. It will also have the same reaction. So yan, masisira yung double bond. The double bond here becomes broken. It becomes single bond here. And then you have the formation of the bond between your bromine and your carbon. So they will undergo the same type of chemical reaction no matter in what organic molecules they are found. So ang point dito, if you have the same functional groups, you have two compounds with same functional groups, more likely they will undergo the same type of chemical reaction. Okay? So that's the first reason. The second reason is more on the properties pa rin siya. So to a large measure, they determine the chemical and physical properties of the molecule. 'Di ba nga in our definition of functional group, sabi doon, ang ang ating functional group, meron siyang predictable physical and chemical properties. When say predictable, yun nga, kapag nakita mo yung functional group na yun present in another compound, then more likely it will also behave dun sa iba pang members ng ating certain family or functional groups. So magkakaroon sila ng pagkakapare-parehas in the physical and chemical properties. So let's say this one. So I'm showing here, this is water and the other one is your alkane. So ano bang napapansin natin? Your alkanes, your hydrocarbons will not mix with water. So that is, yun nga, solubility and density of alkanes. So solubility kasi nga hindi naman nadi-dissolve ang alkanes in water. And what will happen? We will have the formation of two phases. Kumbaga ito sa mixture, this is heterogeneous yung mixture natin. We have the formation of a layer. So the first layer ito, yung ating mga alkanes kasi will float on top of water kasi nga mas less dense. Less dense kasi ang mga alkanes natin. Okay? And we have also ito, this is very true, yung flammability ng ating mga alkanes. 'Di ba? Yung ating ginagamit for LPG. So yung mga narinig niyo naman siguro yung mga methane. So that is a greenhouse gas. So yung mga greenhouse gases natin, yung mga alkanes, they are flammable. So that's why we use them for cooking. So that is the reason number 2. For reason number 3, ito yung very helpful bakit natin ginawa yung functional groups kasi nga these are units by which we divide organic compounds into families. Imagine we have millions of organic compounds present as of now, and we cannot study all of them. So we can study them as a group. So kailangan natin siyang i-divide into families. So that's why we have functional groups. So ito na nga yung ating mga functional groups. You have your alkene, alkyne. Alkane is shown here as a functional group, but sabi ko nga sa inyo, it is not considered a functional group because of the simplicity of its structure. And you have your arenes, haloalkenes, etc., etc. So these are color-coded siya. So color-coded siya because of the different elements bonded with each other. And the last reason is, yun nga, since nalagyan na natin sila ng families, this will be the basis on which we derive the names for organic compounds. So later on in our discussion of organic chem, ay magkakaroon tayo ng pagpapangalan. So, di ba, if you belong in a family, then you should have your name. So, your family, you belong to alkane, but of course, we need to give you individual names. So, for alkanes, you will later on learn that we have methane, ethane, propane, butane, pentane, and etc. So magkakaroon tayo ng pagpapangalan. We will assign names. And the naming will be, hindi siya madali. Take note, heads up. Ang pag-name ng ating organic compounds will not be that easy. So there are rules that we will follow and rules to observe in naming your organic compounds. And that will be our second part of this lecture video. Okay, so we will be dealing with nomenclature or naming of organic compounds. So This will be the first, and I will now stop here. Thank you very much.